our next presenter is going to talk a little bit more about something I've heard about, but I want to learn more about, circularity. And there's various aspects of that I'd like to hear more about. In a conversation earlier, he said that we need to stop building silos and start building lighthouses, which I like the analogy. And so our next speaker is Wilhelm Windisch, and he's from the Technical University of Munich, and his title is The Role of Grasslands and Nutrient Circularity in Animal Agriculture.
So, Peter, thanks a lot. Thanks a lot for also for invitation. It's really a great honor to present these ideas here. And I tell you, I have to rush from one presentation to another because I think it's an important thing. There are some important ideas to the discussion, and not to make it black and white, and to find a way in between. So I also hope you excuse my low quality of English. So I try to do my best. Maybe I should try to make some pointer. No. Okay, we can do it in a second. Okay, I will talk about grasslands, about livestock, and I feel after the two presentations, I feel like that almost everything has already been said, but not from everyone. So many things I can do short. So let's talk about the role of the livestock in using agricultural biomass. And before I start with it, I would like to remember you that we are facing not only climate crisis, we are facing also the crisis of having enough agricultural area. So during the next generation of human beings, there will be a severe shrink of available agricultural area. So just to show this in a simple figure, all of you know the size of a soccer field, yeah, and so everyone knows. And this soccer field now must feed 3 people at the moment, and one generation later it must feed 5 people, and we do not manage it. One man, one human must die by starving. Yeah? And you see all the effects of the Ukraine war. It is nothing else but an artificial shrinking of agricultural area. You see all the impacts what it has. Even if it occurs in another place of the world, but it has severe consequences to the local economy. So what is agricultural area? What is agricultural area? And what can you eat? Just go into the landscape and then ask the people, what can you eat from what you see here? Left figure, you can eat nothing. And also in the right picture, it is a prospering wheat country. Most of the biomass is not edible, it's non-edible. So agriculture does not produce food. It's not true. Agriculture produces biomass, and most of the biomass is not non-edible. What is non-edible biomass? So well, it's absolute grasslands. Yeah? Absolute grassland. It's crop rotation, co-products which you harvest automatically together with maybe you see the mouse here. Okay, you harvest together with the harvest like straw, and also processing byproducts. So let's talk a bit on absolute grass. Why absolute? Absolute grassland means that this grassland you cannot convert into arable land for purpose of producing human food of vegan origin, because of simply of climate. It's too wet, or it's too dry, or the vegetation period is too short, like in the alpine areas. Because of topography, it's too steep. It is periodically flooded, and even if you would convert it into an arable land, you would release dramatic amounts of carbon dioxide. We should not do. And this absolute grassland absolute grassland. It has 70%, more than 70% of the global agricultural area is such kind of absolute grassland. So I go back to the soccer field. What does it mean? It means only the penalty area. So this small area, the penalty area, this is arable land. And this is how you have to feed five people with vegan food in the next after the next generation. That's the situation we have. And we are very happy. I'm very happy that I'm living in Central Europe. In Central Europe, Germany, for example, Austria, we have 30%, only 30% of the total agricultural area being absolute grassland. Still 30%. And I learned in Ireland, it's 90. Yeah? So the people in Ireland, I can imagine thousands of years ago, they would be very happy if they could utilize more than 10% of the agricultural area as arable land, because then they could feed more people, but they could not during history. So grassland, what is grassland? It has also already been said. So I have a comparison of a picture. Up is it's East Africa, a grassland. It is not mass keeping of livestock. This is wildlife, thousands of animals. Yeah, and in the forest, no animal. Almost you don't see anything. So the density of big mammals is around 20 times higher in such grasslands. I could have taken a picture from North American prairies or from North European tundras with the reindeer. So it would be the same picture, 20 times higher density of large animals. Why? Because grasslands, together with the herbivores, they evolved with the ruminants, some 30, 40, 50 millions in a symbiosis, producing a whole habitat. This habitat is highly productive. Why? Because of a very quick turnover of nutrients. So this animal is eating, and here it releases the droppings. So the turnover of biomass is very quickly. And what is agriculture? What is wheat? Wheat is a grass. So what we are doing with vegan agriculture, we are imitating some kind of grass. It's nothing else but this. And also it has been also already said, it's Pablo Manzano, this animals, also if we have livestock, sheep or whatever, they produce such kind of landscapes. This is Central Europe, this is anywhere in the hillside, typical area of sheep, yeah, with extremely high biodiversity. So this comes with nutrients. So this is grassland. Another aspect I would like to draw attention from you, it is, okay, crop rotation we know, and co-products we know that we have always straw, yeah? But circularity and byproducts, it does not finish at the gate of the farm. The story continues until the food industry. Do you feed on sugar beets? Do you feed on rapeseed? No, you eat sugar, you buy oil in the shop, you buy rapeseed oil in the shop. And when you produce 1 kilogram, when you buy 1 kilogram of rapeseed oil, you have produced 2 kilograms of rapeseed extracts, which is a non-edible biomass, inevitably. Yeah, this is produced inevitably along all this process. And if you sum up this, then you can give a distribution. This is Central Europe, typical like Germany, Central Europe, where we have only 30% of grassland. This is the distribution of the whole biomass, which is harvested by agriculture. Germany, last 2 years, 2020, 21, each year, 150 million tons of dry matter harvested by agriculture. And 20% of this is grassland. 20% of all the biomass, so it's a huge amount of biomass of this grassland. Most people just ignore, yeah. And this grassland is fed to livestock, and the livestock produce manure. So there's an old sentence, yeah, from the farmers. They say, meadow feeds acre. Meadow feeds arable land. So it's maybe you can see from this 20%. 3% is crop rotation. Crop rotation, it's clover or alfalfa, and you know that the prices for mineral fertilizer are exploding right now because of the of our energy crisis. Yeah? And if we are forced to introduce this kind of nitrogen collectors into the crop rotation, it means that at least 20% or 30% of all the agricultural area will be covered with clover to collect the nitrogen by a biological way. It will increase this segment up to 20%, to down to here. Okay. What else can we see? Straw. 30% is straw, inevitably, when you produce. Yeah. And then the other segments, 20% is 20 and 12%. These are the harvested goods: wheat, barley, oats, sugar beets, potatoes, legume seeds, oil seeds, and so on. And 1/3 of all these harvested materials is byproduct. So when you buy flour, you have 1/2 kilo, 1 kilo flour will produce almost 1/2 kilo of bran. So all the byproducts, so we need to include the industry, the food industry, into all these aspects, and summing up, taking all together that in this way, on the current situations, only 20% is vegan food of all the biomass. So in this calculation, I assumed that no food is produced on arable lands. So all the harvested goods are channeled into the food industry, not into the feed industry. So it means 1 kilogram of vegan food provides, on average, 4 kilograms of non-edible biomass. A huge amount of non-edible biomass. It depends on the area where you are living and on your systems. It's anywhere between 3 and 5 kilograms. And I would encourage you to do this calculation on your own ground, in your area. The data are very simple to collect, but until now, nobody is doing this. And most of the NGOs, they are afraid of these figures because they don't like it. 1 kilogram of vegan food bought in the shop, in the grocery shop, in the shop, generates at least 3 to 5 kilograms of non-edible biomass. You have to recirculate it. You have to channel it back into the circulation. These are huge amounts of plant nutrients. Agriculture is regularly doing this. Yeah, without circulation, you would have increased. You would have increased the nitrogen fertilizer, the phosphorus fertilizer by factor 5 to 10. So it's impossible. You have to recirculate. You have three strategies to do this. You can do it either just putting on the field and leave it on the field and let it rotten. This would be the vegan agriculture. This is inefficient because the release of plant nutrients is at any time, but not at that time when during next year, the plant culture requires the nutrients. It's very ineffective. The other way is fermentation to biogas or feeding to livestock. In both cases, you have a storable organic fertilizer. You can store this fertilizer, you can keep the plant nutrients, and you can apply it next year or at any time when the culture, the plant culture, the food delivering plant culture really needs these plant nutrients. And there are many studies showing, and here's one example, the nitrogen efficiency. So these three strategies, vegan agriculture, biogas, and here there's an example with dairy. So just from a perspective of plant producing, the nitrogen efficiency of just leaving on the field is only half of the other strategies. Efficiency only half, what does it mean? It means emissions. It means nitrogen emissions. It means also nitrogen dioxide. Nitrogen, what's the name in English? The Lachgas, these N2O emissions. Okay, but you cannot eat methane. So if you have it, if you feed it to dairy, you have a win-win situation. Livestock promotes, you clearly see livestock promotes vegan production in addition and produces food in addition. You see here the production of cereal units per hectare here is double if you apply storable fertilizer and not leave it rotten, let it rotten on the field. Okay, how much is it? How much is the food you can produce in addition? So everyone can calculate this for its local conditions. So I have it done for the conditions we have in Central Europe. If you take this 3 to 5 kilogram of non-edible biomass, let's take the scenario of grasslands, of ruminants, then you can produce 3 kilograms of milk. 3 kilograms of milk in addition. Of course, you have to feed the whole system. You have to feed the offspring, the young animals, and the dry cows, but the whole system will provide 3 kilograms of milk. Or you take the byproducts, you feed pigs, and then you have ½ kilo of meat. And these amounts of extra nutrients, of extra food produces, this is from the kilocalories and from the protein, 50 to 100% of this 1 kilogram of vegan food. But just by circularity, just by circulating these 3 to 5 kilograms of biomass, you almost double the amount of nutrients, amount of food you get from a certain area. So this is a huge amount of extra food you gain just by circularity, just by livestock, without any addition. Of course, this produces emissions, yeah? And emissions, and we have to, and then you can compare it with in terms of efficiency. And the most important thing is food competition in this way. So let's take a little picture on efficiency. This picture shows you how much protein, pure protein on the plate of the consumer you can receive with 1 kilogram of feed dry matter. 1 kilogram of feed dry matter, it produces around 80 grams of protein with chicken meat. If you feed it to chicken, 80 grams of chicken meat of protein means around 240, 250 grams of meat. I'm talking about pure protein. And for ruminants, if you have beef production, it's only about 8 grams. So there's factor 10 between the efficiency. So on the newspaper, the guys of the newspaper will say, oh my God, ruminants are so inefficient. So let's go chicken. They are most efficient. They require the fewest resources and they exhibit the lowest footprint. That's true. But what they eat? They eat human food. So all these high efficiency, low emissions, they are bought by food competition. And this poor beef animal, it didn't consume any food, it just consumed non-edible biomass. And feeding ruminants just seems to be inefficient. It just seems to be inefficient and dirty, but at absence of food competition, it's the most efficient way to make use of it. And interestingly, the pig is anywhere in between, because the pig can do both. Pig can feed on highly concentrated material, highly efficient, but it can feed also at low efficient, low quality material, as we have done the last thousands of years. So pig is very flexible. The only problem is methane. It was already addressed in the lecture before, in the presentation before. Methane. Methane. Is it methane with the ruminants? Do we need methane? Why do ruminants produce methane? They need methane. It's something which stabilizes the ruminant functions. And of course you can reduce the methane, but you always will have a certain methane burden of milk and of meat from ruminants. And if you like to do some breeding strategies to reduce the methane, you will quickly come to a limit. It's like an aeroplane. It's like an airplane. An airplane has always wheels. You need wheels to take off and to land. The airplane does not need wheels to fly. So you could say, okay, let's take away the wheels. But there's a limit. Otherwise, if you make the wheels too small, it cannot take off anymore or land anymore. So it's like this methane. Methane, of course, and it was already said, a strong greenhouse gas, but it has a very short lifetime in the atmosphere. And here's a picture. This is done by a colleague in Austria. This is the radiation, but it's not the global warming potential 100. It's the physical effect of the radiation force. Where's the mouse? Radiation force, and the contribution from 1890 to right now. And you see there's a small band of methane. So methane itself, if we do not increase the numbers of animals, the emission of methane is in an equilibrium with a degradation of methane from former emissions. So the total concentration in the atmosphere will not change and it will not heat up. Absolutely in contrast to CO2 to the carbon dioxide. So we should not focus too much on the methane. We should focus on mitigating the carbon dioxide emissions. So what is if we take it together? If we take it together, it means this biomass, this inevitably occurring biomass, 3 to 4, 5 kilograms. The emissions will occur. The carbon will be emitted. The nitrogen will be emitted. It doesn't depend on the pathway how you recycle it. It can be, you can let it rotten on the field, or you can feed it to the biogas plant or to ruminants or to animals. It will have the same emission. So if we do not feed this to animals, the consequence on the environment is zero. The only thing is we have less food. And the vegan agriculture must then double the food production on a limited area of arable land. And this is simply impossible. Of course, if you have too much, if you grow feed on the field, on the arable land, then you produce emissions, and livestock has to pay for it. So I will, for the reason of time, you're standing and I skip this and I go to this last two pictures. What is happening if we really would reduce, if we really would focus on non-edible biomass, on this inevitably occurring non-edible biomass? It would have a consequence that we have 1/3 less ruminant products, less meat. We have 70% less pork and 95% less chicken products. Of course, it's we limit the quantity of feed and we limit the quality of feed. And the quality affects mainly chicken production and for a great deal also the pork production. So ruminants would then be the animals to maintain food security, and we have to maximize the efficiency of transforming this low quality material in a maximum of feed. So this is a scientific challenge. So take-home message would be: don't spoil biomass, neither edible nor non-edible. Of course, along the sequence, food, feed, energy. Of course, we need to maximize the gain of edible vegan biomass from arable land, but we will still have a lot of non-edible biomass. And this we have to utilize. We should not spoil it. We should make use of it, and we can make use of it only with livestock. And the impact of livestock by considering this, integrative livestock has two steps. One step is the basal production, as long as it is in harmony with the circularity, with this data I showed you, then it's protecting, it helps environment. And if you go on top over this, this 3 to 5 kilogram per kilogram of vegan food, then it may stress the environment. And we have to discuss how far should we go. This is a public discussion we have to do, yeah. And we should find in future an acceptable balance between plant and livestock production based on these things I told you. Thanks a lot.
So I really liked the soccer field analogy. Thank you. I've been struggling using the apple illusion of if you take an apple and you cut it down until you only have 1/32 of an apple, and you take the peel off that 1/32 of an apple, that's the arable land that we have to grow the crops. And so as we're having these conversations, the protection of that resource is one that doesn't receive sufficient attention, especially when we get into issues of land development for housing, the loss of arable lands to produce expansion in urban areas is a major issue as well that ought to be brought into the conversation. I very much appreciate the introduction for me on the concept of circularity. And we could imagine that we've got nutrients being supplied in plant source foods that aren't as utilizable by human beings. So phosphorus would be one example that if we provide it in cereals or legumes or nuts, that phosphorus or phytate phosphorus is essentially unavailable to our use. And so now let's think about the form as well as what we're removing and pulling systems together. So